Hello everyone, welcome to my channel. I'm Varsha. So from today onwards, you will learn about a 7th semester subject, that is artificial intelligence and machine learning, and many more subjects in 7th semester. So since you already know that we do have released a timetable regarding the exam, so I have started to upload all the videos regarding the subjects and regarding the exams. So let's start with the first subject, that is AIML. In that first module, that is artificial intelligence. So let's begin with this module. So in this module, we will learn about what is artificial intelligence, problems, problem space and search, and heuristic search technique. This is a very small module including only three topics, that is problems, problem space search, and heuristic search technique. So let's begin with the first one, that is what is artificial intelligence. So in order to learn this artificial intelligence, you need to learn all these five definitions, which is very important. First one, that is data, information, knowledge, intelligence, and artificial intelligence. So let's start with the individual one, that is data. Data is nothing but a raw facts, and the information is nothing but manipulating and organizing the data. From here we need to organize and manipulate the data. From the information what you have gained, you need to understand what to do, and the knowledge what you have gained, and you will understand or will learn how to apply this one. So that is how we will gain this intelligence. So artificial intelligence is nothing but making the computer to do the things which people do better at that moment. So here people will do that task better than the computers, but here what we are trying to do is, here we are making the computer to do that things. So say for example, you are extracting one gold from gold, you are doing a gold mining from the, you are extracting the gold from the earth. The first what you will get is, you will get the raw material, correct? So from this what you will extract is the gold, correct? And the next thing what we will do is, you will think what you will do, what to do, that is you think whether to make a jewelries, bangles, what you need to do. So for the next thing you will get the knowledge, and intelligence is how to apply the solution or how to do that. So that is what you will learn in the intelligence. And once you learn that, you will make or you will think that all the procedure can be done with the help of computers, right? So all these procedures can be done with the help of computer. So that is how you train the computer. That is nothing but artificial intelligence. So that is the artificial intelligence. And moving on to the next concept, that is AI problem. Here we have a lot of problems in AI that is discussed here. There are three main problem, that is game planning and then theorem proving, and common sense reasoning, and GPS, that is general problem solver. Game playing and then theorem proving, in order to prove a theorem, say for example Pythagoras theorem or many more theorem which are available in our syllabus or any other syllabus, that is, in order to prove that theorem, it requires a lot of knowledge. Still AI is learning to prove that theorem. So that is a one problem with the AI. And even in game playing, in order to play a game which is not simpler, is very difficult task, that is a problem with the AI. And the next one is common sense reasoning. Here it does not have any kind of common sense. That is, when we have to define a relationship between the objects and the a human being or any other physical object, then it will be difficult for the AI to find out the relation between them. Say for example, I have one wooden table and I have one tree. So in order to define a relationship between these two objects, it is difficult for AI to define that relationship. And the next one is general problem solver. So several common sense tasks will be difficult for the computer. So that is what is discussed in the AI problem. The first one is game playing, and the theorem proving will be difficult, and the next one is common sense reasoning, and the third one is general problem solver. So that is the AI problem. And the next one is, here what you are looking is nothing, these are the applications. So they forgot to mention the title over here, but remember what you are learning here is nothing but the applications or applications of the AI. So here we have three different types or categories of applications of AI, that is mundane task, formal task, and then expert task. So the level from mundane to formal, formal to expert is increasing. So that is, with the help of artificial intelligence, we are able to recognize the vision, speech, and even understanding of the natural language, and even common sense reasoning, and even robot control. So this is mundane task, and with the increase of the level, so we are moving on to the next one, that is formal task. So formal task nothing but with the help of AI we are able to develop the games, for example chess or any other games, and with the help of AI we are able to do the mathematics, that is geometry, logic and even integral calculus, and proving the properties of programs. So that is what we are doing. This is very basic level compared to the problem discussed in the above before concept. So, and the next one is from formal task we are moving on to the next, that is expert task. So here expert task means the level is increasing. With the help of AI we are able to do the engineering, scientific, medical and then financial analysis. So these are the three different areas of the application, that is mundane, formal and then expert. So remember all these are having a different levels of AI. This is the very basic level, and the level increased and very high level of advanced AI what we are using in this expert task. This is about applications, and moving on to the next concept, that is physical system symbol hypothesis. Yeah. So let's start with physical system symbol system hypothesis. Here in this system or in this hypothesis, so let's learn what is this. So in the mid of 1970s and 1950s, during that time many hypotheses were arising. So one of the hypotheses is symbol system hypothesis, which is related to the AI training. So what it says is physical symbol, it's nothing but it has following these four concept or four features. What are those? That is symbols, expression, symbol structure and system. These are all the concept which we have in the symbols physical symbol hypothesis. So physical symbol system contains symbol, expression, symbol structure and then symbol system. First of all, what is this symbol? Set of entities is nothing but a symbol. A physical pattern exists between the symbols is nothing but expression. So number of instances together is called a symbol structure, and the collection of process to operate produce other expression is nothing but the procedure. So say for example here have a plus b. So a is nothing but a symbol, a plus b is nothing but the expression, and next one is symbol structure. Number of instances of the symbols, that is this one, number of instances together, that is a plus b into a minus b. This is the number of instances we get. So that is the number of instances together we call a symbol structure, and the different symbol structure together we call it as a system. Different symbol structure together we call it as system. So physical system consists of all of these tasks. So what does this hypothesis says is a physical system has the necessary and then sufficient information for general intelligent action. So I will repeat. So physical symbol system has the necessary and then sufficient means for general intelligent actions. It says that the physical system what we have defined is enough or is sufficient for training an intelligent action. In order to train the machine, this is enough as per this hypothesis suggests. So this is about this hypothesis. Let's move on to the next concept. AI technique. So in order to solve any kind of problem, AI has a few techniques. So that is what here we discussed. The first one is knowledge capture generalization. Here we have what we have is, here we have 1 2 3 4 5. This is the data, or this is the knowledge we have organized, but we have to generalize it to the in normal terms, right? So what we can do, we will take 3 as average. So that is what we will do, that is we capture knowledge capture generalization. We generalize the normal knowledge what we have captured, and the data what we will do here, it will be easily understood by the people. So that is the second step. And the third step is the data what we have must be modified to the correct errors, and the changes must reflect to the real world. So and then the data what, or the method what we follow is modified to correct errors and reflect changes in the world, reflect the changes to the world. And the next one is it will apply to the many situation. The solution what we are proposing will be applied to the many situation, even if it is not totally accurate or complete. Even if it is not 100% accurate, it will be applied to the most of the situation. And the next one is, it will help to overcome the sheer bulk, help by helping narrow ranging of possibilities. So if we have thousands of ways, what it will do is, it will identify the optimal or the best solution. So what we are doing is, here we are bulking with the bulking solution is narrow reduced to narrow range of possibilities. That is the next one. And moving on to the next concept, that is criteria for success, that is Turing test. So this is one of the important question. What we will do, we will explain with this diagram. Yeah. So here we have two types of machine in a two different room. For example, machine X and then person X. Person A. So what is this test is doing is, whether the machine is mimicking the human or not. So this test is done to identify whether the human or whether the computer is mimicking the human or not. So first, let's take an example. So what are the characteristics of the human? I have given one, sorry, where it is gone. Yeah, I'll just zoom it out. Yeah. So I have given on math problem, say for example 1 2 3 4 into 1 2 3 into 1 2 into 500. So this is a math problem I have given. So I have given this to human being and a computer. Okay. So how much time a normal human being would take in order to solve this problem? He may take 15 minutes maximum if he is the average at mathematics. So if I give this solution to the computer, it will give in 0.5 seconds. True or not? So the properties of the human is, he will take the maximum time, say for example 15 minutes. Even though he will take the that much of time, he may give correct answer or wrong answer. If the answer is wrong, then we can definitely say that the answer was calculated by a human. Okay, if the time taken by that person is very very less, and the given correct answer is right, then we will definitely say that this is a machine. So in order to mimic the human, the machine should take the maximum amount of time, and sometimes it should give the wrong answers also. Then only we will be confused by whether the answer is given by the human or computer. So that is the characteristics. So let's see what this test is all about. As I said, so the machine will be separate. Machine and the human will be placed in a different separate room, and the one person who is interrogating will be will give the problem to both of these rooms. For example, the same math problem what I explained to this one and this one also. So both of them will take 15 minutes of time or even more by this system or this system, and they will both submit the answer. Now if the machine takes 15 minutes of time and the human takes 15 minutes of time, if the machine gives answer as wrong, but human with the wrong calculation, he also gives wrong answer. Now this person A will be definitely confused by to identify which is machine and which is human being, because they both possess the same characteristics. So that is why this person will be confused whether this is machine or this is machine. So now the machine has passed the test to pass the Turing test. This is all about the Turing test. And the next concept is here we have an overview of the artificial intelligence. So simply go through that. The next concept is problems and heuristic. So how can you define a problem? Problem which can be caused for different reasons. If it is solvable and solved in a number of different ways. So we can define a problem as which can be defined or which can be caused for different reasons, and if it is solvable and the solved in a number of different ways, then we can say it is a problem. So that is the definition. And definition of a problem as a state space search. So how can we define a problem as a state space search? For example, we have problem what we are doing is, so say for example here you have this 6 blocks. I'm here, I need to go to this state, that is goal. What we are doing here is we are moving or we are searching for the goal state. So that is nothing but a problem. And problem solving, if I reach from this position to this goal state, then we can easily say that problem is solved. Correct? So that is nothing but problem solving is nothing but searching for a goal state. So in order to solve or methodology of the state space approach is nothing but identifying the final state. We will start with the initial position and we will end at the goal state or the final position. So methodology for the state space approach, that means to identify the state space we follow few steps. That is, first we have to represent problem using the different state, as I said, and identify the initial position, initial state and the final state. We have to identify both of them and determine operator for changing the state. For example, so from here, if I need to move here, then I need to walk. This is the operator for changing the state. If there may be any other case, that is, if I multiply by some value or if I increase the value, then I can move from this state to this state. So then the next fourth step is we need to identify the operator for changing the state. And the next one is represent the knowledge problem in a convenient form. So we have to represent the knowledge. Knowledge is nothing but related information regarding this. All the information regarding this state is nothing but the knowledge. We have to represent in a convenient form and start from the initial state and search the path to the goal state. We have to start from here and we have to identify the proper goal. So that is the state space approach method. And so they have explained with an example of chess. So first we have to identify the structured format and the different states, and we have to identify the initial state, final state and operator, that is we need to move the pawn from one position to another appropriate position, and we have to represent the knowledge and the initial, and then we have to search the path to the goal state. That is nothing but the chess. And the production system, so in the previous semester you might have learned in a computer graphics and even in and one more subject is you have learned, that is ATC. There also you have learned regarding this production. So production is nothing but a set of rules. So production system, so for the entire procedure for getting the solution of AI can be viewed as a production system. The definition is here: entire procedure for getting a solution for an AI problem can be viewed as production system. And set of rules is nothing but the left side or a pattern that determines applicability of right side, that describes the operation to be performed. In other words, we can say that operation to be performed if the rule is applied. So that is a set of rules. Knowledge means the information appropriate for a particular task. I have explained that one. And a strategy, so if it is the proper strategies, that is a proper order, we need to move from goals to the so in order to move from requirement, so that is nothing but control strategy. And the next one is production rule. Rule is that this is if and then condition. So here what we will do is, if this condition applied, what is the consequences, that is what we will do, and we will identify the steps and the algorithm. Here is the algorithm. It's a simple algorithm, that's the same step which will follow the same step as I explained before. Here it will first we have to represent the initial position, and first we have to represent the initial position, and if it is the final state, then we have to directly quit. That is, if it is goal state, go to the step 5, else we have to move to the step 3. Choose the position and apply the changes. Now change to the new state. So again we have changed the new state. Again we have to identify whether it is a final state or not. If it is final state, end. If it is not final state, go to the third, and again change the state, go to the second, and if it is final state, go to the fifth state, and if it is not final state, go to the third step again. So that is what we will do in this algorithm. So there are different types of production system, which is not much important. And moving on to the next one is problem characteristics. This is very important. Here we will define whether the problem is a decomposable or not, steps can be ignored or not, this is absolute or relative solution, is the solution is state or a path, which kind of problem it is, what is the role of knowledge, like that we will have the we have to analyze the problem. Okay, so the first one is decomposable or not. For example, I have one square. In this I'm drawing a 4 art. Here I need to draw one house, and here I need to draw one tree, here I need to draw one boy, and here I need to draw one girl. What I can do is I will call 4 people to draw individual. So I will call 4 people, so that this people will draw house, this people will draw tree, this will draw girl, and this guy will draw girl. So this is how I divide the task. At final I will get all the output which contains house, tree, boy and girl. So similarly, the problem which we gave to the system is we will identify whether the problem is decomposable or not, whether it can be divided and given, or whether it can be divided and solved separately or not. Here for example, you need to identify cos 90 plus sin 90. So this is the problem. First, what we can do is we can separate. Cos 90 can be given to me, and I can give this sin 90 to you. So I will say as cos 90 as 0 and sin 90 as 1, and I will add, and I will tell the result as 1. So now what I got is answer from you and the answer from me, and ma'am will calculate the total answer and she will say the answer. So that is how it is calculated, right? So now similarly here we can decompose this. That means we can divide the problem and we can calculate, and we can extract the answer from each individual person, and we can get the final answer as individual, one single answer from the system. So that is nothing but the decomposable problem. If it can be divided into different parts, then we can say it is a decomposable. And the next one is if the steps can be undone or ignored. With the help of the 8 puzzle game, we can explain this. 8 puzzle game is nothing but this is the puzzle. The numbers are shuffled here, and the one block will be empty. Here the task is to arrange the numbers in this manner: 1 2 3 4 5 6 7 8. So what we need to do is we need to move the block from here or here or here to the empty position. Then only we can move. Here what we can do is if I move 6 here and if I move 8 here, then what I can get is I can either move 2 to here or 3 to here. So which is of no use? Let's take which is of no use. What we can do is we can undo the task what we have done. That means I will reverse the procedure what we have done. So I will again move back to 8 here and move back to 6 here, and again I will get this empty space again. So that is, here we can ignore few steps. Here we can also undo the steps what we have done. That is how we can classify whether the problem is whether the problem can be ignored or undone. And the next one is universal predictable. So sometimes we know the output of what we are trying to do. For example, in 8 puzzle game, we know that what we have to do in the output, correct? We need to organize that in a proper pattern. So that is nothing but a universal predictable, whether we know the output or not. So that is so that we can confidently move towards the solution. So that is nothing but universal predictable. And the next one is good solution or not, whether the solution is absolute or relative. So say for example, here you have related information, that is Marcus was a man, Popian, and born in 40 AD and was died, and etc. etc. All the information is given regarding Marcus. Now the question is whether the Marcus is alive or not. So this is the question. You need to answer this question with the help of this data. So whether I can answer this data or not, whether I answer this question or not, obviously I can answer, that is the Marcus is died. All the Popians were died, but Marcus was Popian, so he also died. So we can easily say that the Marcus is died. So what we got here is, here we got this answer to the question, but here we don't see the solution, or we don't see the path which they have followed. This is called as any path problem. Here we don't care about which path they have followed, but at last we got the answer. That is enough. So that is nothing but absolute or relative solution. And the next property is the solution is state or path. So what we will do is, if the solution is state or path, when we are taking the example of two kinds of problem, that is one is two kinds of problem, that is one is water jug problem and another one is state of the world problem. For example, I said here in the statement, the bank resident ate the dish of pasta and salad with the fork. Correct. This is the natural language. So here what we got two types of problem, that is water jug problem and natural language problem. Here a natural language understanding is the state of the world, that is here we care about only the state, or here we care about only the solution. But in water jug problem, the important thing is path, how we have done that. So water jug problem I will explain now. So that is nothing but two kinds of problems. That is state or a path. Statements it cares about only about the final state. Path means the path they have followed in order to find that solution. It is important. So what is the role of knowledge? Role of knowledge is here, in order to play the chess we have to and knowledge is required, that is the related information about the particular task. So the role of that knowledge is very very important. How can we define that? So that is the knowledge. And the next one is so does the task require an interaction with the person or not? Whether the human interaction or human intervention is required or not, that is will be defined by the characteristics of the problem. And the next one is problem classification. You can easily classify the problem based on the solution or kind of problem what we have given and the solution what we have got. So that is the problem classification. And the next one is water jug problem. Here this is very very important. The algorithm and the production rules, everything is explained in this water jug problem. So let's take how it is derived, or what is this water jug problem. So here, just say for example, here you have 4-liter water jug and 3-liter jug. So the solution is, you need to fill this 4-liter jug by only 2-liter with the help of this 3-liter water jug. So I will repeat, you have one 4-liter jug and you have one 3-liter jug. So what you need to do is, you need to fill this 4-liter jug by only 2-liter with the help of this 3-liter water jug. What you can do, I will explain in simple words. That is, what we can do is, first I will empty this. I will delete and I will write 4-liter and then 3-liter, 4 and 3. What I will do is, first I will empty this one. And the next thing, what I will do, I will pour 3 liter of water into this. Step 1, 3-liter into 4-liter. What I got? Now I have filled this 4-liter by 3-liter. Correct. Still only 1-liter is empty. Again I will fill this 3-liter jug with water and again I will pour this to 4-liter jug. Now only 1-liter space was left. So I can fill only 1-liter here. 1-liter will be filled and remaining 2 liters will be left out in the 3-liter water jug. Now what I got? The solution, that is 2-liter water. I got 2-liter water. Now I can empty this water 4-liter jug with all the water it contained. I can now fill this 2-liter water jug which was in the 3-liter to this 4-liter. So that is the solution. So first 4-liter was there and then 3-liter was there. First I will fill this 4-liter with the 3-liter of water. Now it has got only 1-liter of space. Now again I will take this 3-liter and I will pour this 3-liter water into this. Now only 1-liter can be filled in the 4-liter. Now this will fill the 4-liter by 1-liter and the remaining will be 2 here in this water jug. Now we can empty this 4-liter and we can fill this 2-liter here. So that's the solution. So we have a lot of productions and rules for this, and this table is also very very important. I will explain all the problems which will come in this module in the next video. So this and the next we have chess, same problem, production rule and a table will be displayed, and also 8 puzzle problem. So that is also there, and traveling salesman person, that is also there. And next one is the Tower of Hanoi, and monkey and banana problem. This is all problems related to this module. And next one is missionaries and cannibals. So these are all the problems which is there in this module. And next one is control strategy. This is the last concept. This is the last concept of this module, that is control strategies. So here let's take on one question. So while solving a problem, so the one question that arises is how to decide the rule, or how to decide which rule to apply next during the process of searching for the solution. For example, as I said, I need to move from here to here. I have lot of path. So how to do, which rule need to apply in order to while in the process of searching the solution. So we need to identify which rule we need to apply, correct? So that is a next question arises when we have solving the problem. So that is explained. Here we have breadth first search and then depth first search. You have learned regarding this. Breadth first search is nothing but first breadth will be analyzed, and the depth first search means depth will be analyzed first. For example, here you have a tree. Correct. So first, what we will be analyzed in breadth? First it will come to this, then it will go to this node, and then it will move to this node, that is neighboring or the child node. And once it will finish this neighbor node, next we'll move on to this child node of this node, and child node of this node, and child node of this node. And once it completes this node, it will move to the neighbor of this one, that is child node of this node. So that is how we calculate in the breadth first search. When we go to the depth first search, first what we will do, first we will go to this child, and we will go on to this child, and again we will go to this one and this child node, and again this and this and this and this. This is how it is calculated. So that is the depth first search. And there is a simple algorithm. First we will take one node list and empty node list. We have to loop it until the node is empty, and if the node is empty, then we have to quit. So we have to apply the rules, and if the new goal state is the final state, that is, then we have to quit and return. If it is not a new state, then we have to add the new state to the node list. We have to add that new state to the node list in order to explore its child node and everything. So that is the breadth first search. We have a similar kind of algorithm for the depth first search also, and so that is the depth first search and then breadth first search. Now what we are learning here is heuristic function. Now as of now we have learned depth and then breadth first search, how to analyze the solution while we are traveling. So in the next we will move on to the heuristic function. Heuristic, let's understand what is this heuristic. Heuristic is nothing but a rule of thumb used to help to guide a search. A thumb rule used to guide search, help the guide search. So here it will guide whether we are choosing the optimal path or not. And the next one is heuristic function. This function is applied to the state in search to indicate whether the solution we have chosen is likelihood of success or not. For example, let's take this path. This is the goal. I will draw. Yeah, so here a person is standing, and this is a goal, and here you have one open door. If and this is a death door. Okay, so let's take an example. This is an open door, and here if he reaches from here to here, he will wins. So if we take the path here, then the percentage of his success will be 0. Not 0, 10%. So if he chooses this path, and if we move to this path and this path, or if he takes this path, then the success rate will be 90% or 50%, and chance of likelihood to get that goal state is more. Correct. So that is the percentage, or that is the heuristic function. It defines whether the path we have chosen is likelihood to reach the success or not. So that is the heuristic function. Then heuristic, it's a thumb rule to define It's a thumb rule to help to the guide. It's a thumb rule to help the guide to search. And the next one is heuristic function. So here it will say that applied states or search is likely to indicate the states if that state is selected. So likelihood of success if that state is selected, that is nothing but the heuristic function. So this is about this module. So the problem related to this module will be explained later in the upcoming video. So thank you for watching.